Welcome to our AgTag launch party. We're delighted to have you here to celebrate a momentous milestone in what we've been developing behind the scenes here at Aggregates is our AgTag product. And I'm really looking forward to the team walking through their aspects and what they've participated in developing this next generation technology. So over the next few minutes, we're going to go through our acknowledgements and our overview of the actual product. We're going to have Eric and Forrest walk through actually what it is and the product we've developed. We're going to have Matthew talk about how AgTag actually fits in with this product and how it's going to empower the next generation of machine learning. And then we're just going to have some general discussion, questions, and networking. Obviously, we're going to go to the stockyard and have a beer. So that's going to be the highlight of the end of this session. But I guess I wanted to give where have we come from and how have we gotten here, and the overview of that over the last 4 years of developing AgTag, but also since the fruition of Aggregates itself. So we looked at when we want to improve animal welfare, which is part of our vision here at Aggregates, we wanted to obtain individual animal data, and that really comes in a couple of different formats. We've got environment, nutrition, and health, which really can be aggregated from the farm level, to behavior, which we identified that we also need better data around these particular type of biometrics. Those together make up the mental welfare health of an individual animal. And that's our ultimate goal, to be able to identify both the positives and the negatives so we can have better insights in how we handle, manage, and produce with animals. So when we think about obtaining these animal behaviors, we want things like head shake, head bobbing, gait analysis, etc. And though understanding those things directly target improved health, improved sustainability, improved food security, and increase in precision management. That over the life cycle and assessing that gives us that welfare state, which are indicators like lameness, mobility score, hygiene, etc. But the main problem as we try to ascertain that type of data from a variety of different on-the-market sensors is that we were faced with a huge amount of black box algorithms. So we had siloed data. We couldn't get it from these companies that wanted to provide it, but even when they wanted to provide it to us, it was in black box form, so summarized. The validation and accuracy, we're going to show you some information that we've been working on over the last couple of years on that, where it was not suitable to the type of analysis we wanted to do to be able to understand that individual. So to get to that next generation of technology, we really had to look at those challenges and take them forward into the product that we've developed, which is what we're going to talk about in terms of AgTag. But you can see we didn't just start this and create this product. This is something we've been talking about since 2022, when we actually went to the European Federation of Animal Science and discussed, well, what are the standards for basic behavior and welfare indicators, and how do we start ascertaining those from these digital systems? So then in 2023, we actually came in and talked about, well, what is black boxes data, what is summarized data, and what is raw, unprocessed data that we can then use towards our machine learning. Then last year, in 2024, we then went back to EAP and we presented how to integrate inertial measurement units, our sensor, into calf behavioral analysis. And Matthew here has done a whole bunch of different analysis, putting that data through machine learning models and looking at the accuracy of the outputs from them. That's really fueled a whole campaign of work over the last 12 months and products that we've launched, like AgTag, which we'll talk about. But equally, we're coming back again this year to show and highlight how, by using different filtering and methods with the data, that we can actually train machine learning to a higher accuracy with these techniques, and opening up and bringing the industry and researchers along with us and the tools and technologies we are engaging and developing here at Aggregates. Again, to show that this isn't just something we've plucked out of the sky and developed, this is something we've been intricately part of. And in 2023, when Dr. Cantor moved from Guelph University in Canada down to Penn State to be part of the animal science department, it was an opportunity to be like, wow, You see the problems with sensors, we're developing a sensor. How can we work together to implement our technology to get you the data that you need for this higher intelligence on calf behavior? So we started with our breadboard, which we literally developed in 2023. And now we have our own PCB that we're selling, we have clients who have purchased it, and what we're launching here to you today in a variety of different houses. So to get into what is the market doing and why this product that we developed. Back in 2023, we also had an intern from Penn State who came on board and helped me understand the layout of the market for dairy and beef technologies in general terms. And these were digital or software technologies. And we began to see that there was a bit of a pattern. Majority of our technologies come from outside the United States. 66% come from outside. Majority of that is Europe. We only have in PA, which is our home headquarters, 3 AgTag companies. And here in Colorado, where our engineering base is, we only have 2. And we're part of those. So we've got a huge, we need to grow these types of industry. We need to grow the technologies that other companies are going to adopt and use. And we think what we're doing here is part of that as we go forward. Taking and building on the work that I've just shown you in that last poster, with Matthew, myself, Elena, who was our intern from Penn State University, we've gone even deeper into specific what sensors are out there. And we've seen about 58 different sensors on the market with summarized black box algorithms, unstandardized outputs that we really couldn't make head nor tail of. But looking at the literature, we've seen that there's actually, again, a pattern, that there are issues with the outputs and the standards and how we're even writing about that in peer review. So we turned that into an invited scoping review of precision livestock farming sensor recording, dairy cattle behavior, and recommendations for future validations. So we decided not only just to research this, but to become the subject matter experts in this topic, and what leads us with such passion to the product that we've developed here today. And going even further before we founded AgriGates, in 2016, when I worked for another technology company, Dr. Tom Parsons from Penn State actually asked me, how can I get aggression and sitting behavior from sensors? And no one had really developed a pig-specific sensor. And today, on our side here, you can see ethograms of different behaviors from sows that we've collected. That's a first of its kind from the technology that we've developed. So that's taken nearly a decade to go from asking that question, is that possible, and obtaining it now today. And we're moving forward with more projects with this partner to further develop out our sensor and our technology capabilities. And that has been funded by the Pennsylvania Center for Poultry and Livestock Excellence, where we took our neck sensor, which we started with, and how could we shrink that down and make it an ear sensor for sows and swine applications, even cattle applications. And now, on the completion of that Center for Poultry and Livestock Excellence grant, we're now adding in 2- and 3-dimensional cameras and audio data into our suite of sensors that feeds our machine learning edge compute, and equally into AgTag, all parts that we're going to talk deeper about as we go through this presentation. So it's with great excitement and a lot of hard work that I'm ecstatic to introduce AgTag, which we believe is the next generation of food animal behavior sensing that's specifically built for AI and the era that's coming. This fits into the bigger suite of what we've got here at AgriGates, and I've mentioned this just a minute ago. We've got AgTag, which we launched on the 9th of August last year, and we continue to make updates on this as we go forward. We're launching today our AgTag sensor, which is the next generation of behavioral sensing. And we have coming down the pipeline our Ag on Site product that is going to be the next generation of machine learning compute for the farm level. So keep an eye out, and we look forward to introducing that to you in the near future. All of this is not possible without all of the different people that are engaged with AgriGates and the projects that are here. And I think to start with, the actual Terry and Jim, they're founding members of AgriGates who support us immensely in the subject matter experts, oversee what we're doing, make sure we're going in the general right direction, but also the financial support to what we're doing day to day. and our team behind the scenes doing the engineering. And on this project, led by Eric and Forrest, but Matthew behind the scenes supporting with a bunch of software and AgTag components. I'm extremely proud and thankful for the work that they've done, and I'm excited for them to get up here and introduce what they've been working on.
Alrighty, thank you so much, Dan. I am very excited to launch AgTag to you guys today, specifically the AgTag RM1, that we call our Research Module 1. And yeah, I want to jump right into it, talk to you about what is AgTag, what makes it different from other welfare sensors, what it enables. Specifically, we're marketing AgTag as a research-focused device. So we're focusing on getting high accuracy, high frequency data to research partners so that they can use that to build machine learning models, do AI and different algorithmic work. They need a platform to actually collect reliable data from, and that's what we're going to provide to them here today. And specifically, there's two kind of points that I want to mention. A big thing that sets aggregates the AgTag aside, there's really two important points, is the high frequency that we output this data at. We're not outputting summary data, we're outputting specifically high frequency samples, and we're outputting quaternion data as well. I'll jump more into that, but that is the rotation of our device. And just to go down the feature list, we're launching a variety of different mounting options, as well as our device is a rechargeable device. So this is not a one-time use, deploy, and when it runs out, that's kind of the end of the life cycle. This is something you can keep recharging and keep collecting information on. So what I want to go into specifically is what that high quality data is that we're recording. Traditionally, with most accelerometers, with most sensors, you're only going to see acceleration data. So they're only using free axis inertial measurement units and only looking at movement. We are collecting 9-axis data. So in addition to that accelerometer, we're also collecting gyroscope and magnetometer data. That information is giving us specifically the rotation of the device. So through the models we have on the sensor itself, we're outputting gravity-corrected linear acceleration. So with traditional accelerometer data, you have your 9.8 meter per second squared offset on whichever axis is gravity. We're filtering that out. So your ML model, your analysis doesn't need to worry about, am I looking at the actual animal movement? Am I looking at animal behavior? Or am I just looking at gravity on the analysis side? We're also outputting what's known as quaternion data, and that's a representation of the orientation of the device. So you know with orientation data, you know that regardless of how the device gets mounted, you know what direction that impulse is. So you can imagine if we're looking at head shake, with normal acceleration data, you're kind of hoping that, oh, I remember mounting it in this orientation, I see it on the x-axis, that looks to be left and right movement. With the quaternion orientation, you actually know exactly what direction that is. And we're collecting all of that at an incredibly high frequency. So we're recording at 10 hertz. So we're collecting all of that information 10 times a second, and we're storing that continuously 24/7. We've also included a real-time clock or RTC unit on our device. This is collecting, has millisecond accuracy timing data. So then when you get to line up your data with, let's say, your video source or your audio source or any other sensor, everything's already lined up. You have a accurate timestamp to look at. You're not trying to fiddle around and fudge it back and forth. So let's actually take a look at what some of this data looks like. And the demo that I have for you guys is specifically looking at that quaternion and linear acceleration. On the right, we see the orientation of the device. And on the left, we're looking at the gravity-corrected linear acceleration. As soon as I picked it up, we see a jump in samples. Kind of hold still here for a second, let it settle down. And depending on the orientation of the device, I can create x-axis data in red, I can do y-axis data in green, z-axis data in blue, and that's all relative to how I'm holding the device. If I rotate that, those axes rotate with the device, but we do see with the quaternion data we have an accurate representation of the rotation. So if I spin about the y-axis, about the green axis, we're continually getting that orientation of the device. Or I can switch, and now I'm rotating across the x-axis on that red axis. You can think of, regardless of how that's mounted to the animal, whether it's the neck, leg, or the ear, you know exactly what direction those impulses are coming from. And in terms of part of the feature set for the device, we've seen other sensors where you have to plug them in or put them on a specific dock to do all the data offloading. Everything that we're doing all works over Bluetooth, so we ship the AgTags with what we call an edge device, and then everything is getting automatically offloaded over Bluetooth. You can also get into the device management, so you can manage all your devices over that Bluetooth connection, which I'm actually going to let Forrest take over and get into the details of both mounting and device management.
Perfect.
Thank you so
Eric.
much.
Of course. So as Eric kind of led into with some of the enclosure design that we've gone over, we've kind of landed on 3 main enclosure types to start with, which is predominantly a neck device, an ear device, and a leg device. And we initially started with the neck device as it was pretty close to what we ended up prototyping on the breadboards. But then we were approached by Dr. Parsons, and we were asked to look at making an ear device for swine, as there really isn't much real estate to put a neck device on them. But then it was a question of how can we reduce the weight as much as possible for the welfare of the animal. And so we minimized a lot of the design to approach the ear tag, and then we have just started with our leg tag as well. But with all of these enclosures, we're also able to do custom solutions for more particular needs. But those are kind of the main 3 that we are starting to produce AgTag with. As far as what Eric was talking about with the web portal, and kind of that edge unit that we're shipping the devices with, we have a centralized SQL database running on the edge computer as well, which is a organized, structured way of representing data. So instead of a CSV file where you might just have data points subsequently after another, you instead have it in a structured table format, so you can quickly filter out certain time frames of data, certain data types. So if you only wanted acceleration from 6 a.m. to noon, that's a very easy query to just pass into SQL and then get the data that you actually care about. And in addition, inside of that user portal, you can maintain all of your devices, see their battery, their storage requirements, as well as set up the user credentials for getting notifications, as well as additional users for both that PostgreSQL environment, as well as caretakers of the devices receiving low battery notifications. Kind of all of that is bundled into this ecosystem. And then moving on from that, a little bit more on the specifics of that device manager. One of the other big features of it is what we've been calling device animal binding. So the biggest thing in there is if you want to have a continuous study going on a single animal, and you need to be switching off devices to recharge one while the other is collecting data, the device animal binding tab is really what lets you set up that study. So you can specify, I have this sensor on the animal from this time to this time, and then it's going to be this sensor from this time to this time. And it lets you structure your animal data in a way where you are only looking at the data for that specific animal and pre-filtering and pre-storing your data, rather than then needing to go ahead and sort through all of that data at the end of the study when you're annotating the data or preparing it for calculations. And additionally, Matthew will be talking about this in a little bit, but it also helps with our sister software, AgTag, with actually annotating that animal's data rather than sensor data itself. And then kind of getting into a little bit more of that AgTag transition, in addition to working on the SQL database directly with AgTag, there is also the credentials for accessing that SQL database are universal. So whether or not you want to look at that data in AgTag or look at the data and analyze it inside of R or Python or SAS. Those are all things that you can set up the data flow to be able to analyze the data through multiple venues. But yeah, then just to kind of touch on some of the data that we've collected so far, we already have over 5,000 hours of data, which comes out to 200 million records, or about 4 billion data points worth of data off of the AgTags. So we might not have a lot of prolonged data, but the data that we do have is very verbose, and it already gets us into that kind of big data storage domain. And obviously we are more than willing to talk about quoting, whether that be for the pre-existing enclosures or even starting to look at some of the custom enclosure solutions that we've talked about a little bit. But with that, I will hand it over to Matthew to talk a little bit more about AgTag.
Thank you, Forrest. Like I said, I am Matthew. I've been working a lot with AgTag, the software that we launched, like Dan said, back in August. And now I don't necessarily work entirely with the AgTags themselves. However, a lot of the data coming off of the AgTags is very important to the work that I've been doing within AgTag. Now, like we've been talking about, the AgTags offload their data into a PostgreSQL database, and the AgTag software is able to seamlessly integrate with that PostgreSQL database to access that data to begin doing your annotations. And the AgTag software easily enables you to do machine learning with other external tools such as Python's many AI libraries. And then with all that, you're able to load it into other external software such as Power BI for generating your reports of your data. Now, you can see here annotating data in AgTag is very fast, very seamless and simple. I'm here annotating just lying and standing for this animal, but you can annotate in any behaviors you would like within the software. And since we launched this back in August, we've made many improvements with the tool basically being faster data loading as well as greater control over the data that you load, and then many performance optimizations as well within the actual tool. Now, some of the great benefits within AgTag are it's a very fast, like I said, for annotating in data. A lot of the current systems for annotating data are hands-on, either being in person and writing down what's going on, or having a clicker to log time entries, or watching back a video in order to annotate your data. However, within AgTag, you can do all those, as well as annotate specifically the sensor data itself, which leads to greater behavior identification, such as some very minute behaviors, such as head shaking, or being able to see the transitions of sitting down to standing up, or vice versa. And this prepares the data for your machine learning projects and greatly optimizes the time that you have to spend for these projects, reducing the hundreds of hours that used to be needed of human annotation for making models of your data. And finally, we've been talking a whole bunch about how the AgTag data goes into AgTag. However, it's not just AgTag data. We accepted any data, any raw data, such as the third-party sensor data from the goats in the top right. With all this, we've been working with many partners across the globe, mostly US-based. However, we do have a partner in Canada with the University of British Columbia, as well as some partners in Europe with Ireland and INRA. And I want to give a special thanks to Penn State, Penn Vet, and INRA for their data, which we were using on the previous slide, the cattle data from Penn State, the swine data from Penn Vet, as well as the goat data from INRA. Within AgTag, we have many features coming. Just next month, we have the tabbing feature, which is going to allow users to annotate in multiple animals and multiple video feeds all at the same time, and being able to easily and seamlessly tab between those, as well as later this summer in July, we have the audio component, which will allow users to load in their audio data and listen to their audio data and annotate that, as well as see the audio levels and the spectrogram analysis within AgTag. And with these components, we are going to be ready and launching that as AgTag version 2. Then later this year, we're going to begin the greater machine learning projects, starting with the computer vision, which will be coming out in September. That's going to be able to be tracking the animal and defining zones within the data and automatically detecting those zones and detecting where the animal is within those zones within the tool. And this all leads us to this greater machine learning component in AgTag, where instead of having to export those annotations from AgTag and then using third-party tools such as developing models in Python, you can do that all in-house within the software of AgTag itself, and that will be coming much more down the line. With that, I'm going to hand it back to Eric to finish this off.
Thank you so much, Matthew. Yeah, just wanted to quickly summarize. We've been already quite impressed by what our current partners have been able to output in terms of data, in terms of insights on that data, and it's been very exciting to see them work with that and have access to all the information we have. With that, we're very excited to get this in the hands of more people and get it deployed on more animals, more than just cows and swine. We want to see it really on every type of animal. That comes with the versatile enclosure, comes with the rechargeability. We really want to see it deployed everywhere and kind of set a gold standard for data in agriculture. And we're excited to see that happen. So thank you for attending, thank you for watching, and we're excited to answer questions or